Hey guys, Miss Scott here. Chapter 8's a pretty long one, so let's jump right in. When we're talking about domain and range in Chapter 8, we're talking about graphs that look like this right here. The domain, in almost all cases, is all real numbers, because you can plug in anything for x. The range, however, depends on where this graph is leveling off. So you probably notice here it's leveling off at 2. And it's above this line y equals 2. Well, if it's above, that means the y's could be anything greater than 2. All right, so let's move on to an interest problem. So we're going to use this equation right here, and we have to fill in $2,250 for A. The rate is your interest rate. In this case, we would rewrite that in a decimal form, 0.04. N is the number of times you're compounding per year, and if it's compounded quarterly, that means N equals 4. And then for the time T, we're going to plug in 8. Okay, so let's plug that into this formula and see what we get. We'll end up with y equals 2,250 times 1 plus 0.04 divided by 4 to the power of n times t, so that would be 4 times 8. And when you plug this into a calculator, you always need to figure out what that exponent is. So in this case, 4 times 8 is 32. And if you go ahead and plug that in, you should end up with, let's see here, $3,093.62. So you would make quite a bit of profit on that investment in 8 years. Okay, still using some interest ideas here. We are going to write an exponential model for this situation here. So you buy a house for $75,000. That's going to be our A value. And we're going to write an equation y equals the house, if it increases by 2% or 0.02 each year. And for the years, we'll use t for time. So our amount is 75,000 times 1, and then we're going to do plus 0.02 to the power of t. Since it's increasing, that's why we're adding the interest rate on. And we can simplify that a little bit. This would be y equals 75,000 times 1.02 to the power of t. And you could use this equation to figure out what your house is worth in 5 years, 10 years, 12 years, whatever you want, you can plug in for t. So that's how this equation would be used. All right, moving right along here, we're going to simplify some expressions with e. In number 4, let's go ahead and divide 10 by -2, giving us -5. And then with the exponents, remember we can subtract those. So we get e to the power of 6. And that is it. So there's a few more steps in number 5. First, let's sprinkle this 2 on in. So we won't do anything with the -4e to the 4th, but then 3 to the power of 2 becomes 9. E to the power of 7 times this exponent of 2 would give us e to the 14th. And now we can multiply this -4 by 9, giving us -36, and we can add the exponents in this case. So we get e to the power of 18. All right. Let's move on to some log problems. So if you have to evaluate a log, set it equal to x, then change form. So this would be 3 to the power of x equals 27. And then you just have to figure out what exponent would make that true. And we know 3 to the power of 3 is 27, so x has to be 3. Okay. Let's use that same idea here in number 7 to find an inverse. So if you remember from the chapter 7 semester review, to find an inverse, the first step is to switch x and y. Now what we'll do with this is change the form. So the base is 3, the exponent is x, and that equals y. The third step is to get y by itself. Well, we can skip that step because y already is by itself. All right, now we are given an exponential, and we're going to rewrite that in logarithmic form. So we'll just rewrite the word log. Notice that our base here is 4, and 16 comes next, and that always equals the exponent, which in this case is 2. So you don't need to evaluate or anything, we're just rewriting this in log form. Okay, now number 9 asks us to use a calculator to approximate to 3 decimal places. And in order to do that with this problem, we'll write this as the log of 51 divided by the log of 5. And you can just plug that into a calculator. Just be sure to put parentheses around the 51 and the 5. And if you do that to 3 decimal places, you should get 2.443. In number 10 here, we have to expand, and then in 11 we're going to do the opposite, condense. When you expand a log, the first step is always to drop the exponent in front. So that's going to give us 3 log base 4 of a times b to the power of 6. Then if you remember, if you have multiplication, that expands into addition. So we'll split this up into 3 log base 4 of a plus 3 log base 4 of b to the power of 6. And an expanded log can't have any exponents in it, so we still have to take this 6 down and multiply it with the 3 here, giving us our final answer, 3 log base 4 of a plus 18, 3 times 6 is 18, log base 4 of b. So now that there are no exponents and everything just has one variable in it, that would be completely expanded. So now in 11, let's work backwards. We are going to start by putting all these exponents back on at the end of each of these pieces. So if we do that, we get log base 8 of x to the 4th plus log base 8 of z to the 4th minus log base 8 of y to the power of 12. Okay, and then if you remember, addition contracts into multiplication. So this rule up here works both ways. So if we condense this, we'll just get a single log with a base of 8 of x to the 4th times z to the 4th. And then we still have this minus log base 8 of y to the power of 12. And then another rule we should remember is that subtraction expands into, division expands into subtraction, and subtraction condenses into division. So this is another rule that we used. So if we want to condense this subtraction here, we would end up with the log of base 8, and then we're going to put this x to the 4th times z to the 4th in the numerator, and then in our denominator we'll put this y to the power of 12. So now the word log is only written once, and that's what you have to do in order to condense a log expression. Okay, these two problems here, we're actually going to do some solving. So if you have an exponent that you're trying to find, you should rewrite it in log form. So we'll rewrite this as log base 14 of 84 equals x. And then we'll actually do the same thing that we did in problem number 9. We'll rewrite this as log of 84 divided by log of 14. Just plug that into a calculator. Make sure you got parentheses around those numbers, and you should end up with about 1.679 for your answer. Okay, 13 is going to start the same way, but we're actually going to rewrite this log as an exponent. So 6 to the power of 2 equals negative x minus 4. And then our goal here is just to solve for x. So this is 36 equals negative 10x minus 4. Go ahead and add the 4 to both sides. These will cancel. End up with 40 equals negative 10x. And if we divide by negative 10, 40 divided by negative 10 gives us negative 4 for our answer. All right, the last question does take a few steps, but there are 5 steps. We're going to rewrite this if we know that an exponential equation goes through these 2 points here. The first step is to write 2 equations, plugging in these for x and y in this given equation here. So our first equation will be 6 equals a times b to the power of 1. And our second equation, plug in 24 for y and 3 for x. Now in the second step, we need to solve the first equation for a. So to do that, I'm going to divide both sides by b to the power of 1, giving me 6 over b to the power of 1 equals a. Now what we'll do is take that, and in our third step, we're going to replace a with that equation. So this is step 3. We end up with 24 equals 6 over b to the power of 1 times b to the power of 3. So we just replace a. And if you look at the b portion right here, we can subtract the exponents, giving us 24 equals 6 times b to the power of 2. And now our goal in the third step is to get b by itself. So let's divide both sides by 6, so these cancel, and we get 4 equals b squared. So to get b by itself, we'll square root both sides, and we get 2 equals b. All right, well now we know what b equals, so in our fourth step, we'll plug in b right here to find a. So 6 divided by 2 to the power of 1 is just 2, and 6 divided by 2 is 3, so now we know a. So the very last thing is to just rewrite your equation with 3 for a and 2 for b. So y equals 3 times 2 to the power of x would be our answer.